Hi guys, you're welcome to God Academy. In this lesson, I'll be taking you through the Moivre's theorem. In our previous lesson, we've went through how to find the modulus, the arguments of complex numbers, how to do multiplication, division, and we solved a couple of problems. We continue in this lesson finding the Moivre's theorem. Imagine giving cos 30 degrees plus I sine 30 degrees all to the power 30. Imagine asked to solve this. This is very critical and it's very hard for you to solve this manually. That is why Abraham de Moivre as well as Leonhard Euler sat down to bring this theorem which helps us to do this very easy than you would think. So the Moivre's theorem is a simple theorem in algebra that helps us to do so many things. So imagine complex number z which is equal to x plus iy. When I have z squared, this becomes x plus iy all squared. If I have z cubed, this becomes x plus iy all cubed. What's the meaning of the squared? What's the meaning of the cube? We went through the Argand diagram and realized that I can represent my x and my y, which is the Argand diagram for the complex number z, where the vertical is the imaginary axis and this is the real axis. Whenever you see z squared, it means z has rotated, okay? When z rotates 360, then it means z squared. When z rotates itself 3 times, you call it z cubed. So if you want to find a complex number to the power 30, it means you have to move around this 30 times, right? So the Moivre's theorem is very simple and direct. Let me write it here. So it says that if you have a complex number z raised to the power n is equal to your modulus to the power n cos n theta plus I sine n theta. That is everything that you have to know. So the Moivre's theorem works when complex numbers are expressed in the polar notation. Okay, so given a complex number in the polar notation, z is equal to r e to the power I theta. Refer to our previous lesson to understand how this is done. So if you want to square this, it's simply z to the power n to any power, r e to the power I theta all to the power n, then z to the power n, which is now becomes rn e to the powers multiply ni theta, right? When this simply becomes r to the power n cos n theta because it's cosine of the angle which is attached to the I, and the angle is n theta plus I sine n theta, right? So that is all. This is all you have to know about the Moivre's theorem. So let's see some little applications before we delve deeper to solve more application questions in our subsequent lessons. Assuming I'm giving you cosine of 30 degrees plus I sine 30 degrees all to the power 3. What happens here? I'm supposed to multiply this expression 3 times and to solve, but the Moivre's theorem will tell us that this is simply equal to cosine of 3 times 30 degrees plus I sine 3 times 30 degrees. This becomes cos 90 plus I sine 90. What's cos 90? 0. I sine 90 is 1. So it becomes I. Therefore, the answer of this is of I. See how we've been able to solve this simply using the Moivre's theorem. The Moivre's theorem is used in several applications. Typically, it's used to simplify the powers of complex numbers, the root of complex numbers, and also to find trig identities. I'll see you in the subsequent lessons as I take you through all these applications for you to understand. Stay glued to your seat, follow this course as we move on, and don't forget to subscribe to Guide Academy.